This video is about useful Excel functions, both built-in and Polaris provided. It's part of the continuing series of videos on Excel and VBA best practices that focus on manipulating and accessing external data. This video is brought to you by PolarisInvesting.com, a site for creating defensible valuations. As a reminder, business valuation is based on expectations derived from skillful consideration of past facts and future possibilities. As was discussed in the introductory video to this series of videos, the videos are broken up into kind of the front-facing Excel, what's being called Excel videos, and then we also have several videos on the back, behind-the-scenes VBA aspect of working with Excel. This video is primarily focused on the user-facing, but where required we will talk a little bit about some behind-the-scenes VBA concepts. Look, to start here, I want to first mention a way to comment formulas in Excel. So if we go over here and just look here, using the choose command. Choose is a very straightforward built-in Excel function that simply takes a first parameter and tells out of all the subsequent comma delimited parameters into the function choose function which one you want to have executed. So if you just always select the first one, and this becomes the actual command or function that you're interested in executing, then the subsequent input values into the choose command could be just whatever you want. In this example, it's text, and it's this example of how to comment a formula. So you put in there whatever you want to say about the formula. So very easy way to comment, and then if you really want to make the comment stand out, you can even do it this way, and then that way you have a clear idea of what the formula is that you're actually running, and then a comment that follows it. Next, we're going to talk about Excel built-in functions that are often used when you're manipulating data, primarily text data. I can start off talking about here the trim, left trim, left, right, upper, lower, length, mid, character, and text. Trim function does pretty much as its name implies. It trims off leading and trailing spaces off of text. Left trim just takes off the leading spaces. Right trim will take off the trailing spaces. Left function, you specify the number of characters that you just simply want to take off the front end of the text. Right will truncate how many ever characters you specify. Upper will convert the text to uppercase. Lower will convert the text to lowercase. Now, upper and lower do come into play with some other functions we'll be talking about, because they are some are case sensitive, some are not. So you sometimes have to use these upper and lower case functions to get the text in the proper case. Length, or len, is the length, which just returns the length of the text. Mid is a fairly common function in a lot of languages. It allows you to go extract a certain number of characters midway into the text. So you specify the text string, the starting text, and the number of characters that you want. Char allows you to enter in a number and get back an ASCII character. So for example, if you use the decimal number 65, you get back a capital A. If you input 32 greater than that, namely 97, you'll get back lowercase a. Text is a very useful function for formatting all kinds of text data in date format and decimal places and dollar signs, all kinds of things. Since this video was originally recorded, I've added a brief mention of the DateTime functions here, namely the DateValue and text. DateValue, enter a text string, and then you end up with a DateTime serial number, And then if you want to convert that date time serial number back into text, you use the text function. And you can see some of the other functions that you have here that are similar for time. And then less common date time formulas, which I won't go through. You can read about these here. And then rarely used date time formulas down here. So again, if you want to spend some more time with these less used functions, just pause the video. Next, we're going to be talking about functions highlighted and discuss those. We're going to use a spreadsheet here. You can see here's the list of the different functions that we'll be talking about. So let's look at the search function first. And, unique characteristics about it is it does allow wildcards in the text that you're searching, and they're just standard Windows type wildcards, namely the star, which means anything, and the question mark means a specific character is wild. But the main aspect of search that you need to be aware of is it's case insensitive. It's the only function that we're going to be talking about here that is case insensitive. Here's the actual command that we'll be executing. It's going to go out and search this text up here, John sells apples, and then we're going to be searching for a particular text within that string. So let's do this example here where we look for apple. Well, it comes back and it finds apple at the 12th position. If you count over it, you can see that the A in apple is in the 12th position. But what happens if I search for a capital A? Well, it still finds it because it is at the 12th position. Now we're going to find when we use the find command, which is not case insensitive, that you get an error when it tries to find a capital A apple. What about when we use wildcards? Well, same thing. Search comes back, but find doesn't. And then if we search for something that's not even in the text, we'll get value errors in both those. So let's quickly talk about the find command. Doesn't allow wildcards, is case sensitive. Here's an example of the find. And as we went through the search, we saw the behavior that between search and find. It has primarily to do with the use of wildcards and case sensitivity. Next, let's talk about two common ways to handle handling of when search and find don't find their or result in errors. So let's say this example here, when you're looking for orange and it's just not in the text. Well, if you don't do anything, you're just going to get these value errors. So one of the two ways to handle that is using the IsNumber, and that function will convert any value error to just false. So here's an example of using it, and here's the actual cell that has the formula in it. You can see here that it says if IsNumber, and if it's false, you're going to get 0, but if it's true, you'll execute the actual search. Another approach is to use the IfError function, and it just says if you get an error, 0, otherwise do the search. So we go back to something that's works for both, or works for the search command in particular. You'll see that you get a valid return 12. Something that's not in there, you can just get a 0. Next, let's talk about using replace and substitute to replace text in a text string. The replace function that's provided by Excel is really somewhat useless because it requires you to specify the exact string location. So you can see here an example. We do a replace, and of a string, we have to say how many characters into the string, exactly how many characters we want to pull out, and then the text that we put right in that spot. Now you can see here that the number of characters that we indicate to essentially delete from the current text doesn't have to be equal to the number of characters you put in its place. But the fact that you've got to be very explicit like that, where in the text string and then how many characters to delete, makes it somewhat difficult to use and therefore kind of useless. Substitute is much better to go because you can specify a string here like apple, and it'll search in that string and pull out apple and then replace it with banana. And you can also specify an instance. Now in this case we're specifying the first instance, but it's nice, very powerful to be able to say you want the second, third, fourth instance to be replaced, or you could just leave that off and it'll replace all instances of that. So let's look at a concrete example here. Example here where we're specifying the 12th, starting at the 12th character for 6 characters, remove 6 characters and substitute the word banana. You can see here when we execute that function in this cell, we get John sells bananas as opposed to the original text with John sells apples. Using the substitute command, looking for the phrase apple and replace it with banana. Notice the S stays behind in the original text. John sells apples, so we get John sells bananas, even though we're only replacing it with the word banana. Now, if we flip to the text that we're replacing with uppercase A in it as an apple, you notice here that the replace still works because it's based on a literal location. 12th character in, delete 6 characters, put the word bananas in. But the substitute didn't work because it's case sensitive, so it doesn't find apple. Therefore, it doesn't replace apples with banana, and we get this text here. Well, next let's talk about how you use a combination of these functions to do some very powerful searching, which for instance, is needed when you parse JSON and parse separated values, all kinds of things, where you're more interested in not just searching for the first occurrence of some subtext, but you want to find an instance of it, the first instance, the 5th instance, the 9th instance. So you can do that with a combination of using the substitute command and the search, or substitute and find. So here are an example with using substitute and find. You take the text, you substitute some character. In this case, we'll just say character 2. Well, character 2 is actually kind of a control character in the ASCII set. I think it's actually a start of text or something like that. But this, you're going to substitute the actual text. And here we're looking for apple, and we're going to substitute any occurrence of apple with this very unique single character, character 2. Then we're going to search the text for character 2. Now, before we leave the substitute, we also want to indicate that when the substitute command supports an instance. Here we're just looking for the first instance, but the real power is if you specify the 2nd, 5th, 9th instance, this substitution will only occur on that specific instance of finding the character string that you're interested in. So now when you do a search, it's only going to find the same character that you just substituted in a very unique position in the overall string. And then you end up with your location that's specific to the instance. Now you can do the same thing with the find command. Substitute is exactly the same. But you notice I use different characters. One case I used character 2, and then with the find command I used character 1. Really not clear why character 1 doesn't work with the search command, but it does with this with the find command. So in general, I probably should just use the character 2 as the thing that you substitute with. But just want to be clear that you can use character 1 if you're also using the find command. But search, for some reason, doesn't properly find the character 1. Okay, another thing I wanted to show is how to determine the number of instances that a subtext character shows up in a text string. So here, seeing that we just take the length of string, in this case John sells apples, and we just subtract off the length of that same string where we've substituted, in this case, the subtext L, but it could be a full up phrase and not just individual character. But in this case, we're substituting the letter L, or character L, with blank. So every instance of L that it finds gets substituted with blank. And you can see here we have 3 L's in this text. So when we take the length of it, it's now 3 characters shorter than it was. So when we run the formula, we get 3. All right, moving on to other functions. There is a concatenate function. You can either do it in line with this symbol here, or spell out the word concatenate and then enter your different text strings, comma separated in the function call concatenate. Most people just use the inline ampersand to do concatenation of strings. The SumProduct function has quite a few powerful features that I want to spend a little more time on. So we'll be closing up the video with a discussion of the SumProduct function and compare it to pivot tables. Since this video was originally recorded, Microsoft has released a new function called XLookup for Excel. It can be used in place of the combination of index, match, and then sometimes sort. Now I'm going to quickly review those 3 functions and then how XLookup replaces them in certain situations. This formula here shows a powerful combination of the sort, match, and index functions. This portion of the formula is not really germane to the discussion. It just simply determines the last occupied row in column E. It is the same formula that was previously discussed in the context of cell B2. Let's first look here at the index function. The index function can be used in 2 different contexts. Now the README file that Microsoft provides, they call it the array form or the reference form. And most common, it's used in the context of a reference form. But it also can be used in array form. Right now it's being used in a reference form, but just to show you the array form, I could take this array column E, type in index, the array column E, and then put a 0 as another parameter. And what that does is now returns the array, a one-dimensional array of column E back, and then use it in the existing index function. Now I'm going to shift our attention to the sort function. It has 2 main parameters. One is an array, and the other one is the sort order of the array, either 1 or -1, which is reverse order. The match function takes 3 inputs: the value that you're trying to match or you're searching for, the array that you're searching in, and then the match type. -1 means a value closest to being equal to or greater than the value in F1, namely 6 in this case. The match type -1 requires that the values in the search column be in descending order. Thus had to use the sort function to convert this ascending order into a descending order. So now with the 3 functions discussed separately, we can see in totality what's going on here is that the match goes through in reverse order, finds the matching or greater than or closest to 6, the row that contains that. But since it's in reverse order, then it has to subtract that from the total number of rows plus 1, and then uses that to offset into the actual column E to come up with the number that's in that particular cell. So in this case, it finds 66 is closest to 60, but greater than. Look at the formula right above that that looks for the closest value that's less than or equal. Well, it assumes that the search column is in ascending values, which it is. So you can see the formula, there is no sort, and it uses match type 1. And then where it finds a match, or where it's equal to or less than, then it just offsets into that column and comes up with the number 55. 55 is closest to 60 and less than. The formula above it uses a match type of 0, so that's looking for an exact match in column E with the number 60. There is no exact match. Now if I were to change one of these numbers, let's say this to 6, then you can see here that it'll come back with the number 6 that it finds that matches. Well, now we'll switch over to this other column G. This uses the new XLookup function. You can see that it gives the same results in all 3 cases, yet when you look at it, it looks very similar for each case. And the reason is because when you look at the parameter list, all the functionality that was in the sort, match, index, and IfError functions is now built into the XLookup. Particularly, you've got a match mode, just like you did with the match, and then you've also even got a search that was built into the sort. So in this case here, you're doing ascending search, was what 1 is. You're doing exact matches, which was that 0 is, and then this 0 says if it's not found, what do you return? A 0. So you can see here it couldn't find an exact match, so it's returning 0. Next case, we're saying that we want to put it in ascending order, but we're looking for something that's equal to or less than. And then in this case, we're doing a sort order that's in descending, and we're going to do if an error 0, but otherwise we're going to look for something equal to or greater than. So a much easier way to come up with the same value than using the combination of sort, match, and index, and even IfError. Another relatively new function called the filter function greatly simplifies filtering a range of cells. The filter function takes 2 parameters, namely a range of cells to filter, and the second parameter is filter criteria. Notice multiple criteria can be used by multiplying criteria together in the second parameter. In this example, shown here in column C, column A is filtered to exclude cell values that are blank and cell values of the letter C. In the Excel techniques video, an approach that precedes the availability of the filter function is discussed. But with the existence of the filter function, this approach is now rarely used. Since this video was originally recorded, a creative use case of the matrix multiply function has been identified. Cell C8 of this worksheet has calculated 21 rows that have at least one non-empty cell in the column range C to H. The formula in cell C8 looks a bit intimidating at first. It exploits how matrix multiplication works. Recall, when multiplying matrices, the second matrix must have a number of rows equal to the number of columns in the first matrix. In this case, matrix 1 has 991 rows and 5 columns. Matrix 2 has 5 rows and 1 column. The resulting matrix from the multiplication has 991 rows and 1 column. Each row in the resulting matrix contains a single value containing the number of non-blank values in the selected 5-column range of the corresponding row in matrix 1. Finally, SumProduct function is used to count the number of values in the resulting matrix that are greater than 0. For a detailed explanation of how the formula works, pause the video and review these steps. Note, there's an alternate formula that only uses matrix multiplication, as shown here. For a detailed explanation of it, pause the video and review these steps. All right, let's get into some Polaris functions. Column number allows you to enter in a column letter, like the A, and it'll return back the number 1. If you enter in B, it'll return back to number 2. Column letter does the opposite. If you enter the number 1, it returns back A. For 2, it'll return back B, and so on. Background color function will return back a integer of a particular cell, indicating the background color of the cell, and that's useful if you want to program in VBA some other cells to have similar background. GetRGB, red, green, blue, is another way to indicate color of a cell, and so you input a cell reference and it comes back with the values that you can use to set other cells with the same to the same color. UpdateTime we've already talked about. Random, we'll talk more about that in the VBA video on useful functions. last row and column and distinct sort. We'll talk about that more when we at the end of the video when we talk about same time we're talking about the SumProduct, comparing that to pivot tables. Transpo array, internal rate of return. In the last two here, we'll talk about much more when we talk in the videos on VBA. Okay, next I want to talk about three built-in functions, math-related functions in Excel that it's got some issues that you need to be looking out for, namely the mod, int, and round. So first off, the int command often is used for DateTime. It's a way to truncate off the fractional part and just get the date, because DateTime has the date in the integer portion and the time in the fractional part. So if you just take the int of the DateTime value, you'll get the date. But if you use int to on negative numbers, you got to realize that int rounds down. And so let's take an example. If you take the int of the number minus 7.6, you get minus 8. But if you take the int of minus 7.2, you also get minus 8 because it rounds down. And when you're talking about negative numbers, the more negative, that's the more down. Well, the behavior of the int function comes into play when working with the mod function, because the way that Excel implements the mod function is it really does the following, it uses the following equation. You can see here embedded in that is the int function. But if you look at what VBA does, VBA uses the truncate instead of int. And the big difference between the int and truncate is the rounding. Truncate truly just chops off the decimal portion, but integer does rounding. So if you do the mod command in an Excel formula and then do the mod command in the back behind the scenes in VBA, you'll get different results for negative numbers. So what you want to do is you want to use a workaround when you're dealing with the mod function, and just to be safe, you want to do it on both the Excel side and the VBA side. And what you do is when you call the mod function, you call it with the absolute around the input parameters, and then when you get the mod back, you then multiply it by the sign like shown here. So be careful with the mod, because it can really create some headaches with negative numbers. And the last thing to watch out for is the use of the round. That if you round, let's say, a number A, and you round a number B, and you add those two rounded numbers to each other, they're not always equal to the round of A plus B. A base 10 fractional number is approximately stored in binary, which is base 2, in a computer. And this is a case where that binary representation can result in different numbers. So if you add the numbers A and B, then round, you're going to get a different result than if you round what's stored for A and what's stored for B, and then add them together. Okay, let's move on to the last topic in this video. Namely, we'll talk about SumProduct compared to advanced filter and pivot tables. Now, the last row and column, I mentioned earlier that we'd be talking about it during this time, but no, we'll be talking about it later on when we're talking about useful functions in the VBA-related videos. All right, so this topic we're going to be talking about next, going to use different spreadsheet than we currently have showing. So I'm going to close this spreadsheet down and bring up another spreadsheet that called FilterTest. We'll be using this FilterTest spreadsheet more in the next Excel video in this series of videos. This video I want to focus on this part here on the page 1 worksheet, And what we're doing here is we've got just a list of salespeople that are come from this list, or a very small list, but typically, you know, a list like this would be much larger. So what I'm going to show you would apply to and be more beneficial if we had a lot more of these kind of entries, which is just indicating the salesperson, the day that the sale was made, the quantity of items that was sold, and then what the total revenue was that was generated from that sale. So this shows the 4 salespeople that are in this list over here. But before we just add up the total quantity of items and the total sales, let's say that we want to be a little more specific about what transactions we want to include in this total. And let's say we want to say we only want to include transactions where the quantity was greater than 2 and where the sales was greater than 1,000. Well, to do that, we can use the SumProduct. We could also use the SumIfs, but the SumProduct is just more flexible. It does everything a SumIfs will do and more. So whenever a SumIfs would be used, typically we'd use a SumProduct in the fashion shown here. Now, the thing you should realize about SumProduct is the name is a little misleading, because the operation that's performed across these different parameters that make up the function call, if you put a comma in between them, yes, it's going to be multiplication. But if I do this and remove the comma and just simply have a single input parameter using multiplication, that's equivalent to having a comma. And not only can I have multiplication, but I can use any arithmetic operation. I can use division, I can use addition, subtraction. So really the SumProduct should be thought of more as a SumOperations, where the operation can be quite a few different types of operations. But I'm going to go back to the more normal use of the SumProduct and just have it the different parameters separated by commas. So what we're doing here is we're saying in this column A6 to A100, making sure that it, to include in this total, it's got to be equal to AND in this case for value in S2. Now, this unary operator that's out in front of it, what that does is it converts a true-false condition into a 1 or 0. Therefore, when you do a SumProduct, or do the product between these different input value expressions, you can multiply them. Now, C6 through C20 is the quantity, and since we want the quantity to be greater than 2, you have that, and then the unary operator out front, and then you have the D6 through D20 being greater than 1,000. And because we're taking the product, you eventually want to include just the quantities themselves, because that's what this column here is showing as quantity. So the multiplication from these other 3 inputs to the SumProduct will just be 1 or 0, and then you multiply it. If it meets all those conditions, then you multiply it by the quantity, and then you sum up the values, and then you get 22 for Ann. You do the same thing for John, Mary, Tom, and you see the quantity of items that that include sales where the quantity was greater than 2, and the revenue was greater, or sales was greater than 1,000. Look over here for sales. It was here we will only want to include sales that greater than 1,000, but also where the quantity is greater than 2. So the first part of this SumProduct is exactly the same between the two totals that we're doing. The only difference is what do you eventually multiply it back by? Because you're just going to get 1 or 0 from the first 3 multiplications. Then you multiply it, in this case, instead of the quantity, you're now multiplying it by the sales. And then you get the different values for sales. Do the same thing for John, Mary, and Tom. So this shows you how to do some very sophisticated roll-up type summations of things out of a base set of data without resorting to pivot tables or other techniques. You just simply make use of the very versatile function of SumProduct. Alright, this has been a video on Excel useful functions, both built-in and Polaris provided. Thanks for watching.